forming the deviation angle D3 here, and therefore we will have another deviation angle which is from emergence angle to this incident DF. We extended the faults, and then we get a final divergent angle. Remember, this is I, and this is also I, as I explained for the primary rainbow, and this is I also, and also here will be I also. And when we consider this is net deviations in anticlockwise direction. When we consider the point A and F, we will have general formula as you can see here, point A and point F. We will have a incidence at point A when we observe this line segment, and which has got from here to here is just incidence, and here to here is deviation 1. This is refracted R, then this is plus this is equal to I, then deviation 1 is equal to I minus R, and deviation for point F also is this R plus this deviation 4 is equal to I, then deviation 4 is equal to I minus R. And for point B and D, then we know that this D plus the R now plus R here is equal to 180 degrees, and this because this is a straight line, we know that it has got 180 degrees, and this D3 plus R is equal to 180 because this line segment EDB has got the 180 degrees. And you can see those explanations here below, mathematical D2 and D3 after having D1 and D4. Therefore, the net deviations between the incidence yellow and the purple is anti-clockwise directions. Now the net is equal to sum of all net deviation up to nth deviation. Okay, we substitute this D1, D2, D1, D4, and then D2, D3, as you can see here. Then we remain with a general formula which has got twice bracket I minus R plus 360 degrees minus 4R. Then we want the formula to be as this for single deviations. Now we just take out 2, and here take out 2. Then we will have 2 bracket I minus R as we have for this 2 minus R. This term is constant, plus plus here is twice in bracket 100 degrees minus twice R. Now this is single 100 degrees minus twice R. Therefore this is for one single, and this is twice 100 degrees minus 2R. This terms is increasing as for the whole number, beginning with 1 to the nth terms of total internal reflections, because this represent total internal reflection for the primary is 1, and there it is 1, and for the secondary is twice, and there is also undergo total internal reflection twice, and for the tertiary is the same, and for the false ohm. Okay, now we are arriving to general formula that deviation net for M total internal reflection is equal to twice I minus R, which is this is constant, plus M times the factor, which is 180 degrees minus twice R in bracket. This is general formula as I have explained here below. Okay, now when we come back to our question, we have a questions and these questions, because this is parallel to this one, and our net directions in clockwise directions is equal to 180 degrees, as we have used I is equal to twice R. As we know here is our R is equal to our R here, our R here is equal, this is because this line are parallel, then our R, this is the alternating angle here, is also R. Therefore the sum of R plus R is equal to I. Therefore, our I is equal to twice R. When we substitute to our general formula, we see that the net deviation is equal to 100 degrees as a clockwise direction. Okay. And therefore, from our questions, remember this is radius, and this is radius. When this is 180 degrees minus twice r, 180 degrees minus twice r, remember the remaining here will be twice r, and the remaining angle here will be twice r. And this we put the dotted line and meet at point O, dotted line, and to complete the triangle OMC. That's the ONC. Let us consider these two triangles and apply the Snell laws of refractions for air to medium. And now medium is what is required, but I is equal to twice r. And from TIG identity, when we put twice r here and below is r, then our identity is equal to 2 sine r cos of r divided by sine of r. Now our n is equal to just the twice cos of r. This is our general formula to find the refractive index of transparent spherical objects. Okay. To consider triangle MCO, as this triangle MCO, so that we can find the value of r, then our sign for twice r is equal to opposite to hypotenuse. Remember, hypotenuse is radius, opposite is this distance separation between incident and the emergent ray. Therefore, we will calculate, we substitute the values of d and r, then we find the r is equal to 15 degrees. Then we substitute to this general formula, and we have the refractive index for transparent cylinder as 1.93 approximately. Remember, formations of second rainbow, of secondary rainbow, is the same as that of a primary rainbow, except that the refracted rays is undergoing a twice total internal reflection, and the violet now, it is out of the range of the visions of the observer, while the red is in the range of the vision of the observer, and it is about 52 degrees, while this one is out of the range, and therefore for the secondary rainbow, the formula will be as V R for the primary rainbow, and for the secondary rainbow we add also another R and V. This one is inside and this one is out and of the arc. This one is inside of the arc, this one is outside of the arc. This is for secondary rainbow, and this one is for the primary rainbow. This is simple formula, general form. This is short form to just remember easily how the arrangement of the colors is on the arc of the primary or secondary rainbow. Thanks for watching. Please like, share, comments. Don't forget to subscribe to this channel for more video like this one. Thank you.